Hello everyone. In this video, we'll try to solve a simple numerical on a circuit analysis, but we will try to solve this by using different methods. Out of different methods in this video, we'll try to do with nodal analysis. Okay. So the circuit is given like this here. Three voltage sources are there. 10 volt source. So this is the 10 volt source, and this is 6 volt source, and this is a 15 volt source. All these are connected to three different resistors, 10 ohm, 20 ohm and 30 ohm respectively. Now our problem is to find the current flowing through 10 ohm resistor. So this is the 10 ohm resistor. We need to find the current flowing through 10 ohm. Okay, so in order to apply the nodal analysis, all these three resistors are connected here. Let us say this is the node at which all the three resistors are connected. Now I am considering this as n. If you are able to find the voltage at this particular node, you can easily find the current flowing through this 10 ohm resistor. Okay, now in order to apply the nodal analysis, we need to assume all the currents as the outgoing currents, or all the currents as incoming currents from this particular node. So I am assuming all the currents as outgoing currents. Let us say the current flowing through this 20 ohm will be like this, and let us assume this current as I20, and the current flowing through 30 is like this. Let us assume this current as I30, and through this 10 ohm I am assuming this as the another outgoing current. Let us say this current is I10. Okay, now when you apply the nodal analysis, the sum of all the currents at a particular node is equal to 0. So I10 plus I20 plus I30 is equal to 0. Now I want to find what is I10. So basically current is the potential difference by resistance. So the potential difference in this particular path where 10 ohm is connected. So the potential difference is Vn, potential at n, minus 10 volt by 10 ohm. So the numerator gives us the potential difference between the node n and 10 volt source, and the denominator represents the resistance. So the current is the ratio of potential difference to the resistance. Next, let me write the expression for current flowing through 20 ohm resistor. So it is Vn minus 6 volt by 20 ohm plus Vn minus 15 by 30 ohm is equal to 0. So these are the three currents, I10, I20 and I30. Now solving the this equation for Vn. So if you see, in all the denominators we have 1 0 common, means 10. If you take common, you have Vn minus 10 by plus Vn minus 6 over 2 plus Vn minus 15 over 3 is equal to 0, because I took 1 by 10 as common and I sent 10 to RHS, so that 10 into 0 becomes 0. Now when you take LCM in this particular case is 6. When you take LCM, you will get this as 6 Vn minus 60. These are the first two terms. If you get the LCM as 6, and second term, so it is 3 Vn minus 18. These are the second, third and fourth terms. Next, fifth and sixth terms are 2 Vn minus 30. Total is equal to 0. Now when you multiply both sides with 6, RHS value will not change, but the LHS in LHS 6 and 6 will get cancelled out, so that you will have 6 Vn, 3 Vn and 2 Vn, which is 11 times Vn, and 60 18 is 78 plus 30 is 108. So 11 Vn minus 108 is equal to 0. Now Vn is equal to 108 over 11. So this is the voltage across voltage at the particular node n when you apply the nodal analysis. Now after finding the voltage, see, if you see the voltage, you can say that it is less than 10. You can see clearly that. Therefore the voltage at the particular node n is less than 10 volt. Hence the current through 10 ohm is actually in this direction. It is not actually in this direction, it is in this direction. Now what is current through 10 ohm? It is equal to 10 minus, because 10 is greater than 108 by 11, therefore it is 10 minus 108 by 11 by 10. It is, the numerator is difference between the two potentials, and denominator is resistance. Now if you take LCM, you will get 110 minus 108 by 11 into 10 is 110. Finally you will get this as 2 by 110. When you cancel this out, it is 2 ones and 2 55s. Therefore current through 10 ohm resistor we got as 1 by 55 amperes. So this current we obtained by applying simple nodal analysis. Okay, so in the next video we'll try to solve the same problem by using mesh analysis. Thank you very much.